Very good morning, friends. Today we'll start statistics part. This is very important part of JEE Main. And in this first topic is what? Probability. So let us begin. Probability. Probability is a statistical name for the word chance. In layman's language, we call it as what? Chance. And in a statistical language, we call it as what? Probability. Now, how chance begin? Chance begin because of uncertainty in life. Our life is what? Uncertain. We cannot say that this thing will happen 100% time. So because of this uncertainty, chance begin. And this chance is nothing but probability. So let us start the chapter. Important terms of probability. The first important term of probability is what? Random experiment. An experiment which gives one or more outcomes. Outcomes is known as results. Is known as so ये जा रहा है random experiment लिख रहे. For example, tossing of a coin. Tossing of a coin. For example, tossing of a coin Second, proving a six-faced die. The next is what? Sample space. The set of all possible outcomes is known as sample space. It is denoted as S. Number of points in it is denoted as NS. For example, in the experiment of tossing of a coin, S is what? Head, tail. So NS is what? 2. Second example is what? In the experiment of throwing a six-faced die, sample space is what? 1, 2, 3, 4, 5, 6. NS 6. Then events. Any subset of sample space is called event. Events are denoted by capital letters A, B, C and so on. Number of points are denoted as Na, Nb, Nc, and so on. For example, in the experiment of tossing of a coin, A, B event of getting head, B event of getting tail, and C, B event of getting horse. Here, sample space is what? Tossing of a coin, head, tail. Therefore, NS is what? 2. A is what? Getting head. So your head is what? H. Na is 1. B is event of getting tail. T is tail. So NB is what? C is event of getting horse. There is no horse here. So this will be empty. So NC is what? 0. Next is types of event. Number 1, impossible event. Number 1, this is little bit light. Impossible event. An event which does not contain any sample point impossible event. An event which does not contain any sample point is called impossible event. It is denoted as phi, and n phi is what? Number of element in impossible event is what? 0. Second is what? Elementary event. An event which contains only one sample point is called elementary event. Number three is what? Certain event. Certain means sure. Sure means whatever you want, you must get it. An event which contains all sample point is called certain event. If A is certain event, then A will be equal to S. Then A will be equal to sample space. So Na is equal to Ns. Its probability will be what? 1, whereas impossible event has probability 0. Complementary event. Complementary event let A be any event. Complementary event of A is denoted as A dash or A bar or A raised to C, and is defined as an event which contains all sample points other than the points of A. That is, A complement is what? S minus A. So Na complement is what? Ns minus Na. Then fifth is what? compound event. Let A and B be two events of same finite sample space S. Compound event of A and B is denoted as A intersection B and is defined as an event which contains all common points of A and B. Next is what? Mutually exclusive events or disjoint events. Two events A and B of same finite sample space S are said to be mutually exclusive or disjoint events if they do not have any common point. Any common point. That is, the common points are A intersection B. No common point means A intersection B is what? Empty. Next is exhaustive events. Two events A and B of same finite sample space S are said to be exhaustive events if their union is entire sample space S. That is, A union B is what? S. Next heading is what? Probability of an event. Types over probability of an event. What is probability of an event? Let A be any event of same finite sample space S. Let NA and NS denote number of elements in event A and sample space S respectively. Probability of event A is denoted as PA and is defined as PA is equal to NA upon NS. That is number of elements in event A divided by number of elements in sample space S. Now there are two small theorems. In usual notation, prove that if usual notation is wrong, in usual notation, prove that. In usual notation, prove that 0 less than or equal to PA less than or equal to 1. Very important theorem. Let A be any event of finite sample space S. A is any event of finite sample space S. So what means about A? A will be between impossible event and certain event. Therefore, impossible event is what? Empty is subset of A and A is subset of certain event S. So number of elements in empty set is less than or equal to number of elements in A is less than or equal to ns. Number of elements in empty set is what? 0 is less than or equal to na is less than or equal to ns. Dividing throughout by ns greater than 0. Why ns is greater than 0? For this you must know random experiment, an experiment which gives one or more outcomes. If it gives one outcome, then sample space will have one point which is greater than 0. More outcome means it is always greater than 0. So divide by ns greater than 0. So 0 upon ns is less than or equal to na upon is less than or equal to ns upon ns. 0 upon ns is what? 0 less than or equal to pa is less than or equal to ns upon ns is 1 as required. Prove that pa bar is equal to 1 minus pa. One minus pa. See the proof. Let a bar be complementary event of A. By definition of complementary event, A bar is what? S minus A. So Na bar is what? Ns minus Na. We convert this in probability, so we'll divide by Ns greater than 0, we get Na bar upon Ns is equal to Ns minus Na upon Ns. Na bar upon Ns is equal to Ns upon Ns minus Na upon Ns. So Pa bar is equal to 1 minus Pa as required. Now we'll go to what problems. In first few problems, we have to find out sample space. There are 4 pins, red, green, blue and purple in a disk. Drawer of which 2 pins are selected. 2 pins are selected at random, one after the other. With replacement, state the sample space and the following event. Okay. So sample space will be what? The pins are red, green, R for red, G for green, B for blue and P for purple. So first pin is red, we are replacing and again drawing. So second pin may be red. First is red, second is green, red, blue, red, purple, or first may be green, second may be red, green, 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 blue, green, purple. First is blue, second is red, blue, green, blue, 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 purple. If first is purple, second may be red, purple, green, purple, blue, purple, purple. If you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. NS is what? 16. A is what? Selecting at least one red pen. AB event of selecting at least one red pen. A will be what? Red, red. At least one means one or more than one. Red, green, red, blue, रेड पर्पल, फिर ग्रीन रेड, ग्रीन ब्लू रेड, पर्पल रेड. So these are selecting at least one red. The number of elements in A is what? 1, 2, 3, 4, 5, 6, 7. B part is what? BB event. Two pens of same color are not selected. Not selecting two pens of same color. So B will be what? Red, red will not be there. Red, green, red, blue. Red, purple. Green, red. Green, blue. Green, purple. Blue, red, blue, green. Blue, purple. Purple, red. Purple, green. Purple, blue. So NB will be what? 12. A coin and a die are tossed simultaneously. Enumerate the sample space and the following events. A die. The die is giving you 1, coin may give head. 2, head. 3, head. 4, head. 5, head. 6, head. One tail. Two tail. Three tail. Four tail. Five tail. Six tail. NS will be 12. A is what? Getting a tail and odd number. A, the event of getting tail and odd number. A will be what? One tail, three tail, five tail. NA is what? 3. B, the event of getting B, the event of getting prime number. So B is what? 2H, 3H, 5H, 2T, 3T, 5T. NB is what? 6. And third part is what? Getting ahead and perfect square. CB event of getting head and perfect square. So C will be what? 1H 4 comma H. NC is 2. Find NS for each of the following random experiment. From an urn containing 5 gold and 3 silver coins, 3 coins are drawn. Total coin 5 gold plus 3 silver is 8, and we are drawing 3 coins. Out of 8 coins, 3 coins can be drawn in 8C3, 876 upon 123, 56 ways. Therefore, NS is equal to 56. B part is what? 5 letters are to be placed into 5 envelopes so that no envelope is empty. 5 letters in 5 envelopes can be arranged in 5P5, 5 factorial, 120 ways. NS is equal to 120. C is 6 books of different subjects are arranged on shelf. 6 books at 6 different places on shelf can be arranged in 6P6 equal to 6 factorial, 720 ways. NS 720. Three tickets are drawn from a box containing 20 lottery tickets. out of 20 tickets, 3 tickets can be drawn in 20C3, 20 into 19 into 18 upon 10 into 19 into 6, 1140 ways. NS is what? 1140. Thank you very much for watching the video. We live only once on this earth. If we do right thing, once is enough. हम जीवन में एक ही बार जीते हैं और अगर हम सही दिशा में जिए तो एक जीवन ही काफी है.